In this video, I'll cover everything you need to know about windowing functions in Microsoft Fabric Eventstreams. I will explain each windowing function in detail verbally, visually, and also in table format, so that after watching this video, you know all about these. So stay tuned. Welcome to the video. My name is Alex and on this channel I cover Microsoft Fabric and Azure related topics. In this video we'll continue our DP-700 exam prep series and the link to the entire playlist can be found in the description. This is the episode 6 in this DP-700 exam prep series, and in this episode we will cover Eventstream windowing functions. In the previous episode we covered the basics of Eventstreams, and in this episode we will expand that topic more and cover Eventstream windowing functions that are a core topic with Eventstreams and processing real-time data. Like in every episode in this series, we'll start with the theory section, followed by demo/tutorials on Fabric, and then we end the episode with few questions related to topics covered in this episode, so that you can test your knowledge. But now, let's get started. Let's first start by covering what are windowing functions in Microsoft Fabric Eventstream context. Basically, windowing functions are used in real-time stream processing to group events into time-based segments for analysis. They help in processing continuous unbounded data by applying aggregations like count, sum, average, max, min, etc. Instead of treating the stream as an infinite flow, windowing functions divide the data into manageable chunks. And this chunking or grouping happens in the group by transformation of Eventstream. And in that transformation, we have 5 different windowing functions which we can use. And those are tumbling window, hopping window, sliding window, session window, and snapshot. Next, we are going to cover all of these in more detail to understand how they are different. Let's first start from tumbling window. That is one of the easiest one to understand. In tumbling window, there are fixed non-overlapping time intervals, which means that events in the stream are grouped into fixed size time windows, for example 5 minutes. And the rule is that each event can only belong to exactly one window, because these tumbling windows can't overlap. These tumbling windows are triggered at regular intervals and new window starts immediately after the previous one has ended. For example, if you're using a 5-minute tumbling window starting from 12 o'clock, the window will be from 12 to 12:05, and then from 12:05 to 12:10, and from 12:10 to 12:15, and so on. Tumbling windows are best for periodic aggregations like counting, summing, and averaging data over fixed time periods. And like I already mentioned, the key thing to remember here is that these windows can't overlap, and the one event can only belong to one tumbling window. This window type can be used to answer questions like how many orders were placed in 10 minutes, what is the total revenue generated every hour, what is the average temperature recorded every 30 minutes, how many failed login attempts occurred every 15 minutes. So basically, if in the DP-700 exam you get a question about something that points to a fixed time intervals without any overlap, then go for the tumbling window as your answer. Next, let's break down visually how these tumbling windows work. Let's have a tumbling window with count aggregation and duration of 10 seconds, which means that we just want to count the incoming events in 10-second windows. Then here we have our timeline that runs from 0 to 40 seconds. And on this timeline, we have many events that occurred, so every green dot on this timeline represents an incoming event. You can, for example, think of these as messages that are being sent to our event stream. Then we want to see how these messages would be grouped if we use that tumbling window with 10-second duration and just count the number of messages using the count aggregation. Our first tumbling window starts from 0 and runs to 10-second mark, and it is exactly 10 seconds long. In this 10-second window, we have 4 events that are A, B, C, and D, which means that using the count aggregation, the value for this tumbling window would be 4. Then we have our second window that starts immediately after the first one ends, and in that window we have also 4 events. Then in our third window we have only 1 event, and lastly in our fourth window we have the remaining 2 events. So starting from the first, the aggregate values counted by the tumbling window are 4, 4, 1, and 2. Next, let's go through the same situation but now in table format. Here we have the table representing exactly the same events using the same timeline that we had on the previous slide. And then we use exactly the same configuration for the tumbling window, and and get the same result that we had on the previous slide. Also, when using windowing functions with event streams, we get that window end time column to our output with the aggregate function results. In this case, we only had one aggregate function, that is count, so we only get 2 columns to our output. To clarify things even more, let's highlight from the table on the left which events belong to which rows on our output. So the first 4 events belong to the first aggregation, since all of them are in the first 10-second window. Then the next 4 events are in the next 10-second window, so they belong to the next window and are aggregated to the second row in our output. This logic continues for the rest of the rows, so that all of them belong exactly to one tumbling window and are part of the aggregate made in that window. Next, let's cover the brother of tumbling window, hopping window. Like tumbling window, this window also uses fixed time intervals, but the major difference compared to tumbling window is that these windows can overlap, and events can belong to multiple different windows. Like tumbling window, this window is also triggered at regular intervals, but for this window we have to configure the duration and the hop size. Hop size decides how long it takes for another window to start after the previous one has started. For example, using a 5-minute window with 2-minute hop size, the first window will be from 12 to 12:05, and then the second window will start 2 minutes after the previous one started, so that they overlap, which means that with this configuration the second window will start 12:02 and run until 12:07, and the third window will start 2 minutes after the second window, which means that it will run from 12:04 to 12:09, and so on. This window type is particularly useful for continuous monitoring and for applications that need frequent updates on the recent data. These overlapping windows allow analyzing smoother trends by avoiding abrupt changes between time periods. This window can answer to questions like how many website visits occurred every 5 minutes, updating every minute. What is the moving average of CPU usage every 10 minutes, updated every 2 minutes? What is the total revenue generated in the last hour, refreshed every 10 minutes? What is the average temperature in the last 20 minutes, updating every 5 minutes? So, if in the exam you get any questions that describe fixed time intervals with more frequent updates than the interval itself, then go for the hopping window as the answer. Again, let's do a visual representation of hopping window. Let's have a hopping window with count aggregation, hop size of 5 and duration of 10. And then let's have our timeline and then our events on that timeline. And by the way, these events are exactly the same we had in the previous tumbling window example. Now let's see how these events would go into our hopping windows. Our first window starts from 0 and runs to 10-second mark. 4 events belong to this window. Then now our second window is triggered 5 seconds after the previous window, which means that it starts at 5-second mark and runs to the 15-second mark. This means that these 2 windows overlap, and we have event D that arrived at 7-second mark and thus belongs to both windows. And then we have those 3 events that happened between 10 and 15 seconds and also belong to the second window. So the aggregated count for both of these windows is 4. Then these windows will continue to hop forward from here, and events can belong to 2 different windows with these parameters. And of course we could have, for example, 10-second window with 1 second hop, and then one event could be part of even more windows. But this visual representation would get very messy very fast. Next, let's again go through the same situation, but now in table format. That is the format you are seeing in the event stream. So we have again our incoming events with their timestamps, and then we have our hopping window configuration. And like we went through, the first 4 events belongs to our first window, but also the last of those events, the event D, belongs also to the second window. And then we keep adding those windows according to our parameters of hop size 5 and duration of 10, and see that there is quite a lot of overlap, and thus we get way more rows as an output than in our previous example with the tumbling window. Next, let's cover sliding window. And I have to warn you, since this window type is the most confusing, at least it was for me to understand. So now pay extra attention if you want to understand this one and get your points in the exam. So, sliding window is triggered dynamically based on incoming events. So, the window opens when a new event arrives and is detected. Then the window will look back in time the specified duration and see if there are other events, and those will then belong to that same window. If they are within within the range of the specified duration. Also, the event that triggered the sliding window will trigger a new window after the event that looks forward in time the specified duration. However, since the triggering event will only belong to the window that looks back in time, it is possible that forward-looking window is dismissed if there are no other events happening in the specified duration after the event. So unlike tumbling and hopping windows, these sliding windows don't start at fixed intervals, and they are triggered by events themselves. These are the best for continuous real-time calculations and ideal for calculating moving averages, trend analysis, and anomaly detection. These windows will overlap naturally if there are many events that are happening in clusters, which will then trigger multiple windows to that point in time, and this allows more granular real-time insights compared to the fixed interval-based windows. This window type answers to questions like what is the moving average of stock price in the last 10 minutes, recalculate whenever a new trade occurs. What is the average temperature recorded in the last 20 minutes, updated every time a new sensor reading arrives? What is the total energy consumption over the last hour, updated every time a new meter reading is received? So if in the exam you have a question about updating or calculating something based on event arrivals and receiving new data, then go for sliding window. And especially if it talks anything about calculating something X amount of time backwards from the event itself, definitely sliding window. Next, the same thing we did before, let's visualize this. Let's have a sliding window with count aggregation and duration of 5 seconds. And here we have our timeline and then events on that timeline. This time let's have fewer events so that this won't be so confusing. Now you can think that sliding window will start to scan for events, and it can't find any events within the first 5 seconds. So no windows are triggered and it will continue move forward. It finds the first event on 6-second mark, which will then trigger a window that will look back 5 seconds. And this time only event A will belong to this window since there are no events before it. However, right after event A, a new window is triggered that looks forward 5 seconds, and this will find event B in the 10-second mark. But also event B will trigger another window that will look back 5 seconds, and it will also include event A, since it is in that 5-second window looking back. B will also trigger forward-looking sliding window, but since there are no events after B, this window will be dismissed. Our actual fourth window will be then triggered by event C, and that will be the only event in that window. Then these events in this cluster will start to trigger multiple sliding windows that overlap. And finally, the event E will trigger the forward-looking window that doesn't find any events and is dismissed as a result. Next, let's go through this in table format. Here we have our input with the same events that we had on the previous slide, and then we have the same sliding window configuration and the same output. And like we went through, the first window is triggered by a message A, so that window will end at the same time the message A is received. Then from A we had that forward-looking sliding window that gets only B. And from B we had that backwards-looking window that has both A and B. And then we continue from here in a similar way we did on the previous slide. Also, I will add here a number corresponding to the window on the previous slide so that it makes it easier for you to break this down more if it still feels a bit confusing. Good thing to know that this was, in my opinion, the most difficult window to understand, so it will get easier from here. Next we have session window. These windows have dynamic size based on inactivity, which means that these windows are not fixed and they can end if inactivity threshold is reached. For example, if specified, window can end after 10 minutes of inactivity, or in other words, no events in 10 minutes. These windows will start and end dynamically. New window starts when event arrives and it will start to look forward from that event. These windows will keep running until the max duration or inactivity threshold is reached. These windows are best for analyzing user behavior and sessions, ideal for tracking user activity, customer interactions, or machine uptime. For example, group website visits into sessions based on user inactivity, so that 30 minutes of inactivity means that it will be a new session. These session windows can overlap if used with optional partitions, which means that we would divide data into sessions based on, for example, user or device ID, so that we would be able to track those sessions independently and not count them into one session. This window helps to answer questions like how many website visits were part of the same browsing session, how long does a machine remain active before downtime, what is the average duration of streaming sessions before a user disconnects, how many transactions were completed within each user session. So if the exam asks something about different sessions or calculating something based on downtime, then go for the session window. Again, some visual representation of session window. Let's have aggregation as count again, max duration of our window as 10 seconds and timeout of 5 seconds. This means that our window will end after 5 seconds of no incoming events, or it will have a hard stop at 10 seconds if there is a constant stream of events. Here we have our timeline, and on our timeline we have a bunch of events arriving at different times. Now let's start to add session windows. Our first session window is triggered when event A arrives, and this window is able to reach event B, since it is received 4 seconds after the event A, so that the timeout is not reached. After the event B, our window closes at 11-second mark, when the max duration of 10 seconds is reached. And also the timeout after the event B would be also reached. Then our second window is triggered at 12-second mark by event C, and it will include also event D and E. However, after D and E, we have some gap before event F. So that's why our window will close 5 seconds after our D and E event, which means that the total duration was now only 7 seconds. Then we have our third window that will run that full 10 seconds from event F and include events G and H also. As we can see now, we don't get any overlap since we are not partitioning this data anyway, but it would be possible that we could have different types of events coming in, and then we would start sessions for those independently and have some overlap in our sessions. Next, let's go through this in table format. Again, here we have our input and then our session window transformation and then our output. And based on the parameters and window end time, we can see which message belongs to which window in our output. And here I have also highlighted those messages like in the previous example, so it is easier to break down. Then we have our final window, snapshot. This window is a bit different to previous ones, but very easy to understand. In nature, this is not a window, since this function groups events together that happens exactly the same time. No time duration can be defined for this function, and it is just based on the events that happen at the same time. Snapshot is triggered when a new event arrives. For example, if 3 events arrive exactly at the same time, then they will be grouped into one snapshot window. This window is best for analyzing simultaneous events. It can be used to detect some anomalies, for example, orders that are placed exactly at the same time. Since these are just snapshots, there can't be any overlapping windows because window ends at the same time it starts. If events arrive even slightly different times, they belong to different snapshots. This window type answers to questions like which order were placed exactly the same time, how many error logs were generated at the exact same moment, what is the total value of orders placed at the exact same timestamp, what is the average temperature recorded across multiple sensors at the same time. So if in the exam you see something about events that happen simultaneously, then snapshot could be your answer. Again, let's visualize the snapshot. For snapshot, we have to only define the aggregate function. That is going to be the familiar count in this case. Then we have our timeline and the events on that timeline. Then we would start to run our snapshot function for these events. The first snapshot would only capture event A, and the second snapshot event B, and the third snapshot event C. Assuming that events D and E arrive exactly at the same time, these two would be then captured by our fourth snapshot, and the aggregation would be count of 2. Then our last 3 snapshots would have only 1 event per snapshot, so that those would have the count value of 1 each. Next, same thing as previously, let's go through this on table and row level with the same events. Like we covered on the previous slide, all the other aggregate values will be 1 except the fourth one that captures events D and E, since they arrive exactly the same moment. And here again I have highlighted those rows, but in this case I think this is pretty obvious which events belong to which snapshots. Then on the next slide, I just have a table comparison of these different windows. I'm not going to go through this table row by row and column by column since we have already covered all the points here. This is here just to highlight the key differences of those window types, and you can pause the video if you want to go through this table. Otherwise, we will jump into Fabric and check out how these windowing functions work in action. Before we open Fabric, I would like to know that I spent a ton of my free time creating these videos for you, and that's why I would like you to hit that like button and subscribe to the channel for more DP-700 and Fabric content. This doesn't cost you anything, and I'd highly appreciate that. For example, this video that you're currently watching took me over 10 hours to make. Also, if you'd like to support the channel with a cup of coffee, you can do so by clicking the Buy Me a Coffee link. That can be found in the description. But now, let's go to Fabric. Now we are in Fabric, and here I have this event stream that I have already configured, and this event stream has this custom endpoint that is receiving this message data from this Python script that I have running on my computer. And here we can preview the data, and here we can see that we have these columns that are generated by event streams, and then we have these columns that are coming from that Python script that I have running. So we have the timestamp, and then we have these text messages here, and then we have also message ID for those messages. And I can quickly show you that Python script that I have running there locally. And here we have that Python script that is running on my computer. And this is very similar to that script that we had in the previous video. And if you'd like to get this script and run this by yourself, you can go to the link in the description, and there you can find the materials for this episode. And for this, you would need to install that Event Hub with pip if you want to run this, but basically you would need to configure this in a very similar fashion that we did with the last time. So you would need the Event Hub name from your custom endpoint, and then the connection string that is actually a secret, so in some cases you don't really want to expose this, and then you would start to run this script. And this script will start to send messages to that custom endpoint by using this min and max delay parameter values here. So this will send messages every 0 to 10 seconds, and those messages will be combined from these strings that I have in these lists. So it will generate this random string based on these here and send it to the event stream. And here we can see that it's sending events and waiting that specified second amount that is random between these two amounts. But yeah, let's go back to Fabric. And here I have this event stream that we are running, and here I have already configured these window functions that are processing that data to the event house. And also I'm sending that raw data directly to that event house as well. But yeah, let's go to the edit mode and check out those configurations. And here we have these group bys that are actually used to configure those windowing functions. So basically from this transformation list you would need the group by to be able to configure some windowing functions. And to this first one I have configured the tumbling window, and we can check out the tumbling window configuration here. So for the tumbling window we can specify the aggregations that we want to do, and here we can add more aggregation functions to the same tumbling window if we want. And here we have a bunch of different aggregation functions that we can use. And then we would specify the field that can be used for those aggregations, and then the output name for the column that comes out as a result of this aggregation. But I'm now just using this count all rows and have that as count in the output. But yeah, then we have these options here to specify a group by column if we want to group by the data like we would do in a SQL group by sentence. And here we have the window configurations, and like discussed, the tumbling window only needs that duration. And then we also have this offset setting that can be used to offset the window a bit so that it will take the events that happen in the beginning rather than in the end of the windows. And then I have configured the output of this tumbling window to be written to this KGL database and this table E6 tumbling window. And then we can go to the hopping window, and a very similar configuration here, nothing really new except the hop size has to be configured so it will hop that specified hop size that we covered in the theory section. Then let's move forward to the sliding window, and here we only have to specify the duration, and we can also specify the group by here as well if we want. But yeah, this is a very basic configuration, even though the sliding window is, in my opinion, the most confusing one. But we already covered how this functions in the theory section. And then we have the session window, and for this we have to specify that max duration and also that timeout that we discussed. Then we have also that partition option, so we can track different partitions so that we could, for example, track session per customer ID or device ID, so that we would keep them as individual sessions and not track everything in one session. That doesn't probably make sense in most scenarios. And then lastly, we have the snapshot, and here we can't really configure much since now we are just taking those snapshots here. And one thing that I want to note here, that this development view in this event streams for this window functions is a bit buggy, so it always shows that these windows have arrived on the exactly the same moment when looking at them in this development view. But we can of course check the results in the KQL database to see that we actually have those windows there and we have some correct amounts. So for example, with the tumbling window, we don't have like 713 events that occurred in one 10-second window. That is not correct. But yeah, we can go to the KQL database and here check out how those look. So here we have the raw data, and here we have those raw values that are coming in, and we can see that they are flowing and their interval is a few seconds or so. So like specified in the script, these events are being sent from 0 to 10-second intervals. And then first we have the tumbling window, and here we can see that now we have some proper amounts here, that these are the events that have occurred in the 10-second window. And then we have the hopping window, and here we have also events that have occurred in these hopping windows, and here we can see that their interval here is 5 seconds because we defined that hop to be 5 seconds, so that we can see that every window ends between 5 seconds. And then we have the sliding window, and here we see that these are now random, these window end times. See, sliding window will begin from the event itself, so that these events can occur quite random times, so that these times are not so sharp like they are in this hopping and tumbling window here. But yeah, then we have the session window, and also here we have some random times because this will also occur from the event itself. And lastly, we have some snapshots, and these snapshots all have count of 1 since we are not sending any more than one event at a time. So it is not possible to have anything than one here, because it is not possible that 2 events would leave out from that script at exactly the same moment. Next, let's have some questions about these windowing functions. But before we do that, I would like to tell you about this service or website that I have made with few friends called certiace.com. Here we can find some practice questions to, for example, a DP-700 exam. And here we have over 100 different practice questions for that exam. So if you're interested in getting some free custom-made practice questions for DP-700 exam, go check out certiace.com. And this site works well on mobile as well, so you can use it on your phone wherever you are. And here we basically have some multiple choice questions related to topics covered in the DP-700 exam. And here you can start practicing to the exam with these questions. And we also have a link to the documentation and some explanation about the correct answer here. But yeah, go check out this website. Our first question today is, the requirement is to calculate the average temperature over the last 5 minutes, but only when a new sensor reading arrives. Which windowing function should you use in the Eventstream group by transformation? Is it A, tumbling window, B, hopping window, C, sliding window, D, session window? Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is C, sliding window, since these other windows types won't allow you to look backwards from the event creation with their windows. Let's have another question. A security team is monitoring a banking transaction system for potential fraud. They need to detect accounts that perform multiple high-value transactions in rapid succession but remain inactive for at least 15 minutes before making another transaction burst. Which windowing function should you use in Eventstream? A, tumbling window, B, hopping window, C, sliding window, D, session window. Now think about the answer for a moment and pause the video. I will reveal the answer in 3, 2, 1. The correct answer is D, session window. Session window is best suited for this scenario because it groups events based on periods of continuous inactivity and closes when inactivity exceeds 15 minutes. Tumbling window operates on fixed intervals, so they wouldn't correctly group bursts of activity. Hopping window uses fixed overlaps, but they don't dynamically adjust based on inactivity. Sliding window looks back a fixed time, for example 15 minutes when a new event arrives, but they don't define sessions based on gaps in activity. And this was all that I wanted to cover today. I hope you learned something new about windowing functions with event streams. And if you like to continue your learning journey, check out the next episode in this series. But now I thank you for watching and see you in that video.